Welcome to Deep Learning from Scratch. In this first chapter, we will unwrap the fundamental building blocks behind every modern neural network. We will look inside a single neuron, understand weights and biases, explore activation functions, and watch data flow through a network in glorious 3 dimensions. Let us begin. At the heart of every neural network lives a tiny mathematical object called a neuron or perceptron. Inspired by the 86 billion neurons in your brain, it does just 3 things. It receives inputs, it multiplies each input by a weight, and it sums everything together with a bias before passing the result through an activation function. In compact form, output equals activation of W.X plus B. Weights control how strongly each input influences the neuron. A large positive weight means strong excitation. A negative weight means inhibition. The bias is an extra offset that lets a neuron fire even when all inputs are 0. Together, weights and biases are the parameters that the network actually learns during training. Watch what happens when we change them. Without an activation function, a neural network is just a stack of linear equations. No matter how many layers we add, it can only draw straight lines through the data. Activation functions inject nonlinearity, and that is what allows networks to model the curved, messy patterns of the real world. Sigmoid squashes outputs between 0 and 1. 10 squashes them between -1 and 1. ReLU passes positives unchanged and clips negatives to 0. Leaky ReLU lets a small slope through, fixing the dead neuron problem. Forward propagation is how information travels through the network. Inputs enter the first layer. Each layer computes Z equals X times W plus B, then applies an activation. The result becomes the input to the next layer. Layer by layer, raw numbers transform into rich, abstract features, and finally into a prediction. Let us assemble a real network. 3 inputs feed a hidden layer of 4 neurons, then another hidden layer of 4, and finally an output layer of 2. Each connection is a learnable weight. Counting them all, this small network already has 42 trainable parameters. Modern models scale this idea to billions. That is the foundation. A neuron is a weighted sum followed by an activation. A network is just many neurons organized into layers, passing signals forward. In part 2, we will teach this network to learn using backpropagation and gradient descent. If you enjoyed this, subscribe, and we will see you in the next one.